let's go to heat and temperature. Now, under that, we'll be looking at measurement of temperature. How do we measure your temperature? We'll be looking at fixed points. What we mean by fixed point of temperature, measurement of temperature, thermometric substances. We'll also be looking at gas thermometer. We're looking at resistant thermometer. Those are the types of thermometer. Now, we're looking at what we call your temperature scales. Your temperature scales. Now, after that, we'll be looking at some exercises and entails. Now, what is heat? Heat is a form of energy which is also called a thermal energy that is normally transferred from one body to another as a result of temperature differences between the two bodies. What do I mean? Heat is just an expression or something that is being felt, which denotes what? Change in temperature. If I have a rod now, I decide to hold it at this junction. I decide to heat it up here. Now, you notice that initially, this particular region is cold or is of normal temperature. So to get to a particular point, the heat, you understand, there will be transfer of heat from this region to this region, which eventually now makes it what? Hot. So at that region, it's just a feeling of temperature difference. Are we getting it now? So it's a form of energy also called thermal energy that is normally transferred from one body to another as a result of what? Temperature differences between the two bodies. So heat is also referred to as a form of energy that does work compared to the counterpart temperature. So it does work compared to their counterpart temperature. So if you look at temperature now, temperature is the degree of hotness. You know, that's what everybody knows about. It's actually the true definition. The degree of hotness or coldness. The degree of hotness or coldness of a body. Temperature is the degree of hotness or coldness of a body. Now, difference between temperature and what? Heat. Number one, heat is a form of energy. Do you understand? Heat can be a form of energy, but temperature is not. Do you understand? It is not a form of energy. Do you understand? But a degree of measure of hotness or coldness. Now, heat flows from what? From one body. Check it. From what I just explained the other time, it will flow from one body to another. But for temperature does not flow. Temperature is just being felt once. Now, heat can also be what? Cannot be directly measured with any instrument, because you don't measure heat, or you measure temperature with your thermometer. Now, heat, the SI unit for heat can also be known as what? Joule. While the SI unit for temperature is known as what? Degree Celsius, or what we call degree Fahrenheit. Now, so those are the major differences between temperature and heat. Now, if we proceed, let's go into what we have there. We have the effect of heat on an object. What's the effect? Number one, heat can change the physical and the chemical properties of an object. That is, if I have a body here now, that body is being heated. Change it. Now, if this body continues to heat up or to be heated, now a point to reach where this body structure will change. That's the physical structure. A point to also reach where the chemical constituent of that body will change. That's the chemical change. Are you getting it now? When they say chemical constituent, I'm talking about the atoms, the internal atoms that makes up this body. The internal atoms will change just because of what? Application of heat. The physical structure, the shape of the body will also change just because of what? The application of heat. What other things can heat do? It can alter or increase the temperature of the body. Do you understand? As we've said initially, as you continue to heat this body, the temperature will change. That is, it will become very, very hot. That is, from the normal room temperature it was initially. Another thing is that it can also change the state of a body. That is, from solid to liquid or from liquid to gas. Meaning that if this structure is being changed, it means that if this is a solid rod, are you getting it? If the temperature is being heated up to the melting point, this rod will melt. So it means that the solid has now been converted from solid to what? Liquid. So that is another effect of heat on that body. The last one is that it can cause emission of electron. Heat can cause emission of electron. What do I mean? If you have a body here now, now if you decide to heat it up, there are some invisible objects that will be coming out of this rod in form of electron. Are you getting it? So heat can bring about emission of electron when a particular object is being heated. A lot. But let's come back to what are how do you measure temperature? Measurement of temperature. So temperature is measured by an instrument called your thermometer. thermometer. Thermometer is one instrument used to what? Measure temperature. Now, all thermometer makes use of what? Thermometric substance, which changes with change in what? Temperature. What do I mean? Thermometric substance. For instance, your clinical thermometer makes use of a thermometric substance called mercury. Are you getting it? Hg. Meaning that if you have your clinical thermometer placed under your armpit, if you check in between the clinical thermometer, you see a black fluid. It's not really black, but that fluid is what we call your mercury. So that fluid is what we call thermometric substance, meaning that that's the actual fluid that enables the thermometer reading to be obvious. It is the sensitivity of this fluid that changes the what? You know, your thermometer is calibrated. Let's say this is 0 degrees Celsius, this is 20 degrees Celsius, this is 30 degrees Celsius. It is the tilting of this thermometric liquid that determines the actual temperature of that body. Meaning that your fluid, the fluid in that your thermometer, which is your mercury, is what we call the thermometric substance of that your thermometer. So as we proceed, we will be seeing different types of thermometers and their thermometric substances. Note, thermometric substance liquid are simply the material used in thermometer which helps the change of position with respect to the calibration of the containing vessel, which I have just analyzed now. Oh yeah, the table here, what can we see? Number one, we have what we call types of thermometer. Number one, we have what we call mercury in glass, which is something I've just analyzed now. It's called mercury in glass, or what? Clinical thermometer. So the thermometric substance there is what? Mercury. How does it operate? Increases in volume of mercury with an increase in what? Temperature. As long as the sensitive part of this thermometer experiences increase in temperature, the thermometric substance tends to what? Either increase or decreases. If it increases, it means that there is an higher what? Temperature. An higher temperature is being experienced. And if it decreases, it means that a lower temperature is also being experienced. Let's go to the next one. We have what we call gas thermometer. Gas thermometer. If you ask me, what is the thermometric substance of this gas thermometer? It's just gas. Do you understand? It is the gas that actually what? Responds to what? The increase or decrease in the temperature. Look at the way I operate. Volume of gas at constant pressure. Do you understand? Another type of thermometer is what we call thermoelectric thermometer. Thermoelectric thermometer. So that one has what we call current flowing. Now the last one is resistance thermometer, the resistance of metal. So if you can go through it, you realize different thermometers and their different thermometric substances. Now let's go to what we call fixed points of thermometer. Fixed points of thermometer. Two reference points are so important when constructing your thermometer in your gas thermometer. We have what we call the upper fixed point and the lower fixed point. You must have heard about all this term. There's nothing special about them. What do we mean? The upper fixed point, okay, let's look at water as case study. Let's look at water as case study now with respect to your thermometer. Now, if you are to ask, what is the freezing point? What is the boiling point of water? That's a kindergarten question. They ask you, what's the boiling point of water? You say it's 100 degrees Celsius. Right? Now, what is the freezing point of water? You say it's 0 degrees Celsius. The 100 degrees Celsius is what we can relate to as the upper fixed point. While the freezing point is what we can relate to as the lower fixed point. It's as simple as that. Are you getting it now? But the definition there says that the upper fixed point is the temperature of steam from pure boiling water at normal atmospheric pressure. You can see 0 degrees Celsius is the temperature at which a water boils, and that's the temperature of steam from what? Normal water. Now the lower fixed point is the temperature of the fixed point ice. Do you understand? And water at normal pressure. So you can see that this is the temperature at which water freezes. Are you getting it now? Scales in temperature. We need to understand scales in temperature. Temperature scales are of three types. We have what we call Kelvin scale, we have what we call Celsius scale, and we have what we call Fahrenheit scale. Those three are very important. Now, each of those scales have their what? Upper and lower fixed point, which I'm going to break down here now. So, when you now know the upper and lower fixed point of each of those scales, then you will now be able to convert from one scale to another. I can decide to give you that, okay, what is the equivalent of 35 degrees Celsius in Kelvin scale? You know, automatically this 35 degrees belongs to Celsius. What is the equivalent of 35 degrees Celsius in Kelvin? What is the equivalent of 35 degrees Celsius in Fahrenheit? I'll give you some parameters which you can use to what? Back that up. But let's relax and proceed with the statement there. The temperature scales used globally in most scientists' work is the what? Celsius scale. Now, we now said in which the upper fixed point is chosen as 100 degrees Celsius. Now, and the lower fixed point is chosen as 0 degrees Celsius, which is also the. Now, on the other hand, on the Kelvin scale, which is used in the SI unit, there exists as a lower fixed point to be absolute 0, below which nothing can be what? Cooled. This absolute 0 temperature is found to be what? Minus degrees Celsius. So we'll talk about that as we proceed. Now, we want to now look at, okay, how do we break down, convert degrees Celsius? We are looking at degrees Celsius now and what? Kelvin. So the formula to use to convert your degrees Celsius to Kelvin is 273 plus your degree. Are we seeing it? This is your degrees Celsius. We want to convert it to Kelvin now. Just add 273. Meaning that if I decide to say, okay, what is 30 degrees Celsius in Kelvin? What will I do? I'll just say T equals 273 plus my 30, which will give me what? 303 Kelvin. Are we seeing it? So this automatically becomes the what? The Kelvin scale. The Kelvin scale conversion from what? Degrees Celsius to what? Kelvin. So that has analyzed that. Let's look at the working principles of various thermometers. Number one, we have what we call your liquid in glass thermometer. How does it work?